Hi everyone, it's Bob Crosset, Senior Managing Editor for Water and Waste Digest. I am here today with Lloyd Winchell. He is Associate Engineer for Brown and Caldwell. Thank you so much for being here.
I'm glad to be here. Thanks for having me.
Yeah, so we're talking about a pretty important topic right now, this PFAS and biosolids talk. What is this current issue that people are facing in the utility side when it comes to PFAS and its relationship to biosolids?
Yeah, so there is PFAS in biosolid. It gets in there. The wastewater treatment plant doesn't produce any PFAS. They're just handling the material that comes in with the influence. So they have to, some of that does segregate to the biosolids, and then it's got to be handled somehow, or it ultimately goes out the back door to whatever the final end use is at the plant. Land application, landfilling, some folks incinerate, and others do some other high temperature thermal processes that I'm happy to talk to you about a little more here.
Yeah, why don't we get into that then? There's pyrolysis, thermal oxidation. Could you talk about those technologies? Like what is their role in potentially solving part of this equation?
Yeah, so pyrolysis and the system always includes a thermal oxidizer on the back end too.
Okay.
But the dewatered biosolids coming from the traditional processes would then feed into one of these new pyrolysis systems. And they treat the solids at a very high temperature, and then the pyrolysis reactor itself actually splits the biosolids into what we call biochar, or solids phase, or to an off gas, which is a very hydrocarbon-rich fuel in itself. And that hydrocarbon-rich off gas goes through the thermal oxidizer where it's combusted. And that combustion there, because the biosolids get hot enough to probably evaporate or volatilize the PFAS into that gas phase, then all the PFAS is processed through that thermal oxidizer, which can reach temperatures that we are comfortable with saying can destroy PFAS. And so we're able to handle the PFAS in that sense, destroy it, and produce a clean product that, again, we call biochar, that can be used for any number of beneficial reuse applications.
Yeah, that sounds really interesting. It sounds like you have a lot of resource recovery options here also in the end of there.
Yes, there's a lot of applications, and they're trying to establish the market for various biochar sources or uses, and you can actually tailor the biochar to some sort of spec if you want a certain carbon content or nitrogen content. You can modify the process to get that target. And then, as I mentioned earlier, the off gas is beneficially reused in itself because it is thermally oxidized or combusted, which generates a lot of heat, and then we take that heat and we recycle it back either to the process to drive the thermal reactors, or if there's some left over, you could use it for other things like power generation or heating other facilities within the plant.
That's fantastic. So what are you seeing with some research on this? You guys have been doing a little bit of research, have some studies out there on that. Could you talk a little bit about what you're seeing there?
Yeah, so I just gave a talk here at Left Tech about what we're doing, what others are doing, and so there's two main tracks in our industry looking at faded PFAS through pyrolysis systems. There's the Water Research Foundation study, and then there's the study that we're doing that's supported by WEF. And so we're taking a full-scale facility, we're measuring the major inputs and outputs of that pyrolysis system, which includes a thermal oxidizer, and then we're also constructing, and have constructed actually, a lab scale unit that we're going to take the material from that full-scale system and run it through the lab scale too, and see if we can match those up. And that way, if the lab scale matches full-scale performance, we can do future experiments at the lab scale at a very reduced cost compared to the full scale. Yeah.
That's so cool. You guys have a lot to work on, it sounds like.
It's a very technical field, and I'm glad to be in it. And hey, it just came to us. PFAS really became an issue in the last decade, and it's just seemingly more and more of an issue in the public's eyes. So we're putting a lot of effort into figuring it out for the wastewater industry.
Yeah, well, thank you so much for talking with me. I appreciate you taking the time.
Thanks for having me.
Yeah, and for everyone who's watching, definitely check out our video description below. You can learn a little bit more about PFAS and biosolids. We'll have some resources for you, and we'll see you with the next one.